All right, let's talk a little bit about scientific notation. And there's only two parts. We have a coefficient and a power of 10. So A is my coefficient part, and a power of 10 is the second part. So we just need to know, well, what can my A be? It can be any number. Well, let's see, by definition, A is the absolute value of A that is greater than or equal to 1. So it became 1, 1.01, 1.0001, 1.5. So as long as it's greater than or equal to 1. And it has to be less than 10. So it can't be 10. It can be 9.9999, but it cannot be 10. And another thing is that n, what is n? Well, that's the power of my 10. It has to be an integer and it can be positive or negative. So where are scientific notations used? They're used to change very large numbers or very small numbers in sciences, engineering, mathematics. As you can see down here, it really makes the form very compact. If it's a very, very, very small number with lots of zeros, or it might be a very large number with lots of zeros. So converting, uh, what you do, you actually move how many times you move the decimal point, and you either move it left or right, and that will make a difference whether it's going to be a negative uh, power or is it going to be a positive power or n. Okay, so again, you're going to move your decimal point to where you get 1 or 9 for your coefficient. Very important here. And then depending on how many times we moved the decimal, our power of 10 will be affected. That n is either positive or negative, however many times we moved it. Okay, so let's look at an example here. Here's a very large number, 2,780,410. So for large numbers, your n is positive. For small numbers, your n is negative. And to write something that's a very large number as a decimal or as a scientific notation, excuse me, we move a decimal to the left. So think about, where's my decimal in this number? It's going to be right here. Okay, so I'm going to count how many times I need to move it to make 2 million into a number between 1 and 9. Well, if I move my decimal to here, that's 2.7. So that's greater than 1, but it is also less than 10. Now, if I put it over here, that would be 27. That is not between 1 and 9. So that's very important. So let's see how many times we moved. 1, 2, 3, 4, 5, 6. So my n equals 6. That's how many times I moved the decimal. Now, which way did I move it? Like, okay, so we moved it left uh, to make the number, the very large number, smaller. So that's what we did. Okay. And we know our n is going to be positive because our number was a very large number. So our coefficient is 2.780418. So we use all of the numbers. It's to the power of 6. And so 6 is going to be positive. Here is my coefficient. Double check it. Make sure it's between 1 and 9. It is. It's times 10 to what power? Well, we moved the decimal 6 places. So it's a positive 6 because our original number was a very large number, not a small number. So it's going to be a positive number. So what if you already have a number in scientific notation and you want to make it into standard notation? You want to convert it back. Okay, so you're going to separate the coefficient and power of 10. So let's say I'm gonna just make a number up and let's look at. Let's say I have 1.925 times 10 to the seventh power. And I want to convert that number into standard notation. All right, so I'm going to look at this number right here. Okay, that's my coefficient number. All right, so we're going to move our decimal in the coefficient left or right based on the power of 10. Okay, that makes sense. So let's see, I've got 1.925. Now I'm going to move this either left or right. Well, how do I know? Well, that's where my n comes in. It's a positive number, so I'm going to go to the right. I'm going to make this bigger. And so how many times? 7. So 1, 2, 3, 4, 5, 6, 7. That's where the decimal goes. And we fill this in with zeros. Okay. So my number, final number, remember we took this and moved it to the end. So I would have 1, 9, 2, 5, 1, 2, 3, 4. So we're looking at 19,250,000. And you can always double check yourself um, because how many times did we move it? 1, 2, 3, 4, 5, 6, 7. Good. So I think we're pretty good there. That would be the standard notation for 1.925 times 10 to the 7th power. Let's look at another example. Let me erase that. What if I had, let's try another one. Let's say 2.05 times 10 to the negative 9th power. Okay, that's a 9. And I want to convert that into standard notation. All right, so we're going to look at our coefficient there, 2.05. And so I'm going to move that decimal. Now I need to figure out, is it going to go to the right or to the left? Well, if it's a negative, it's going to go to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And then all of this, 1, oops, covered up my 0 there, or my decimal, 2, 3, 4, 5, 6, 7, 8, and that was my 9th. So we're looking at standard notation 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 05. So that would be a very, very small number. Remember, if my n is negative, you're looking at a very small number. If it's positive, it's a very big number. So you can always kind of check yourself just going back and forth. I always think when I'm converting from scientific notation, if I move it to the left, okay, that's if it's a negative, then it's a left move, less than. Um, if it's a positive number, I think of to the right, and I think of my number line, numbers get bigger. Whatever little tricks might help you to remember uh, converting, uh, use them. Okay. All right. So here's a few examples. So let's see if we can solve these. You may want to pause the video and see what you can do. All right, so we're going to convert 5,280,000 to scientific notation. So the first thing I know, I'm going to have something times to the 10th power. I need to know what that n is going to be. Remember, that's an integer, positive or negative, and we need a coefficient between 1 greater than or equal to 1, but less than 10. All right, so I'm looking at my very large number here, 5 million. So that tells me my n is positive. So that kind of helps me out a little bit. My n is positive, not negative, because I'm going from a large number. It's actually going to be a smaller number. So I want this number between 1 and 10. So if I put my decimal right here, I have 5.28. Okay, that's between 1 and 10. So that's going to be my coefficient, 5.28. And you don't have to write the zeros after it. You can, you don't have to. Now I need to figure out, all right, I know it's going to be a positive number, but what is the number going to be? Let's think about here's where the decimal is. Here's where I want it to be, and we just need to count 1, 2, 3, 4, 5, 6. So it's to the sixth power because that's how many times we moved this decimal to get the number we wanted or the coefficient. All right, let's look at the next one. Now we're in standard, or I'm sorry, we're in scientific notation and we're wanting to go to standard notation. Again, you always, if you notice, you really kind of start with that coefficient and then use your power to determine what you do. So here's my coefficient. I'm going to move it 5. My n is -5. I'm going to move it 5 times, either left or right. Remember, if this is negative, we're going to be working with a very small number. I'm going to move it to the left because if my decimal goes to the left, it makes the number smaller. Okay, so we're going to go 5 to the left. I should have given myself a little more room there. But 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So we're looking at this to be 0.12345. So we got 0.000042. That would be my standard notation. All right, now the very last one wants us to convert a very small number to scientific notation. Again, we're going to work first with our well, you can look at different ways. We know we're going to have 10 to some power. Okay. I'm going from a small number, so I want to look at this. I want this number between 1 and 10, so 7.89 would be that coefficient I'm looking at. And now from that, we just need to figure out how many decimal places did we move? 1, 2, 3, 4, 5, 6. All right, now is it a positive 6 or a negative 6? This was a very small number, so that would make this a negative 6. And again, you could convert this back and see if you got what you started with. So hopefully that's helpful in converting from scientific notation to standard notation and from standard notation into scientific notation.